Hey everybody, it's Mr. N. I'm back with another sample question for our AP test review, and this one is on separation of variables. And this is kind of like how they would present this. There's so many different ways they could present these problems. Some of them are with slope fields, and we'll get into those examples as well. But I don't think on the 2020, I'm just taking a wild guess, they probably won't put a slope field. That might be too hard for you guys to do and upload and grade. But anyway, let's take a look at what we have here and we'll go from there. It says at time t equals 0, a corn on the cob is taken from a pot on a stove and left to cool in a kitchen. The internal temperature of the corn is 90 degrees Celsius at time t equals 0. Okay, so that's kind of important right there. This is our initial condition, its initial value. It's 90 degrees Celsius at time t equals 0. And the internal temperature of the corn is greater than 26 degrees Fahrenheit, or 26 degrees Celsius, sorry, for all times t is greater than 0. And okay, shout out again to my cousin. I'll use the blue one this time. The internal temperature of the corn at time t minutes can be modeled by the function c that satisfies the differential equation dc dt equals negative 1/5 c minus 30, where c of t is measured in degrees Celsius and c of 0 is 90. That was what we had highlighted up here. At time t equals 0, it was 90. Okay, first part, write an equation for the line tangent to the graph of c at t equals 0. Use this equation to approximate the internal temperature of the corn at t equals 3. So we are looking for a tangent line. Well, what do we do when we always look for a tangent line? The first step is to get a slope. We have to write the equation of a tangent, so we need a slope. Oh, look, they gave us dc dt. That's the slope right here. dc dt is a rate, which is a slope. So we need a slope, and we have dc dt as being our slope, which is negative 1/5, and that's c minus 30. So at t equals 0, we are also told that the temperature is 90 degrees, so that tells us that c of 0 is 90. Okay, let's take a look here. Since we are given the slope, we need to determine at 0, we have 90. So we could say that the slope, which is our dc dt, equals negative 1/5, and we're just going to simply put in the 90 right here. And then we'll get negative 1/5 times 90 minus 30 is 60, and that's going to give me a value of negative 12, which we said was our slope. So now y minus y1 equals m x minus x1. You guys know this formula, and that's our formula for the equation of a line. And we're going to put in the points we know. T equals 0, we know that it's 90. So when t is 0, when x is 0, y1 is 90. That's what that means in context to our equation. We know the slope is negative 12, which we just solved. Sorry, this should have been x minus, I didn't leave myself room here. This should have been, oops, gotta erase that. And this should have been x minus 0. The 0 was this x1 value. All right, now let's clean this up a little bit. We get y minus 90 equals negative 12x. So y equals negative 12x plus our 90. And that's our equation for the tangent line. Okay, so that's the first thing. And then it says use this equation right here to approximate the internal temperature of the corn at time t equals 3. So we are just going to put in 3 for our t. So again, we probably should have written this as y equals negative 12t plus 90 in context of that. Or you could have, since our x variable is actually the t, it doesn't matter. You could leave it like that. They'll take either answer. Plus your 90 over here. So y equals negative 36 plus 90. So y will be 54 degrees Celsius. All right, moving on to part B. It says, use d squared c over dt squared to determine whether your answer in part A is an underestimate or overestimate. So since it's telling me to use the second derivative, what I need to do is determine, is the second derivative, and it says here at time equals 3, so is the second derivative at time equals 3, is this going to be, since they want that, is it going to be concave up or is it going to be concave down? And then I'm going to use this tangent line, since the tangent, we have that. If it's concave down, sorry, if it's concave up, the tangent line will be below it. So if I have a situation, let's draw that out. If I have a situation where it's concave up, the tangent line will be below it, so it'll give me an underestimate. If I have a situation where it's concave down, the tangent line will be above it, so it'll be an overestimate. So the tangent lines will all be here like this, for example. Over here, they'll all be below it. So that's how I know what I'm looking for here. So what I need to do is I need to determine on this tangent line, is it going to be above or below? So let's go ahead and find our DC squared. And this is going to be, since we know our DC dt is negative 1/5 times c minus 30, I will take the derivative of this and I'll get d squared c over dt squared is going to be negative 1/5 dc dt. If you're wondering how I got that, take a look. I can just say this is negative 1, oops, this is going to be negative 1/5 c, and this will be plus 6. If I take the derivative here, I'll just get negative 1/5 dc dt plus 0. But now I have this dc dt, so I need d squared c over dt squared, and I need to substitute this in. And I know what it is. They told me what it was right there in the problem. So this will be negative 1/5 times negative 1/5, and then this will be c minus the 30. Cleaning this up, and I will end up with positive 1 over 25 times c minus 30. Okay, so that's my dc d squared. Let's write this up here. Or d squared c over dt squared is going to be 1 over 25 c minus 30. And we have to take this at time t equals 3. Well, we know at time t equals 3, my temperature was 54 degrees Celsius. So we can plug these values in to determine the concavity of it. So now I'm going to say 1 over 25, and then this is 54 minus 30, which would give me 16 over 25. Regardless of that value, we are just looking to see if it's positive or negative. It's positive, so that's going to tell me that it's greater than 0. Since it's greater than 0, that means my graph will be concave up, right? If the second derivative is greater than 0, then it's concave up. If the second derivative is less than 0, it's concave down. Since it's concave up, that means my tangent line will be below it, so that's going to give me an underestimate, because my line is below what the actual values are. So if I'm checking between a point up here, I'm just like making a linear situation and checking a point there, I'll get an underestimate of what the actual value is. So we have an underestimate for this particular portion of the problem. All right, let's move on to the next one. For part C, it says for t greater than or less than 10, an alternate model for the internal temperature of the corn at t minutes is the function h. So now we've introduced this new function h that satisfies the differential equation, that one, where h of t is measured in degrees Celsius. And again, we know the initial condition is 90. And find an expression for h of t based on this model. What is the internal temperature at t equals 3? So again, we're looking at t equals 3. But we're using a completely different equation, and they want to know what the initial equation is. Right here is what they're asking for, h of t. So in order for me to do that, I need to find h of t, which would mean I need the integral of this dh dt. Well, I cannot just simply integrate that as is because the h is on this side. I need to have the h with the dh in order to integrate it. So guess what I have to do? I have to separate the variables before I can integrate. To separate the variables, I have dh dt. We'll write this out. Equals negative h minus 26 to the 2/3. I'm going to bring this whole thing over to this side. So think of it over 1 and cross multiply. So I'll get dh over h minus 26 to the 2/3, and I'm going to leave this negative over here. It doesn't really matter, but it's just easier for me to deal with it if I just left it on the right side. Okay, now at this point, I can integrate each of these. So when I integrate the left side, I'm going to move this up because I'm going to need more room here. And when I integrate the left side, think about what this is. This is going to be h minus 26 to the negative 2/3, right? So I need something higher than that, which would be when I add 1 to it. So that's going to give me h minus 26 to the 1/3. You can take the derivative of this to verify, but if I take the derivative, I have a 1/3, so I need a 3 out in front. This is the integral of what you see there. And then on the right side, I'll have the negative, and then I'll just have a t plus the c. Remember, you don't need the constant on both sides. Just pick a side. In this case, I'm going to pick the right side. So I put it there, and that's where we're at so far. So this is the basics, but I need to find what this constant is now. And how am I going to find the constant? Well, I'm given the initial condition. When I put in 0 for the time, I get 90 for the temperature. So 3 times 90 minus 26 to the 1/3 equals 0, negative 0 plus c, so that goes away. And 90 minus 26 is 64, so 3 times 64 to the 1/3 is what c is. 64 to the 1/3 is the cube root of 64, which is simply 4. 4 times 4 is 16, times another 4 is 64. So 3 times 4 is the c, so c is going to be 12. And we're gonna go ahead and move the problem up over here and continue on. So since c is 12, I will get 3 times h minus 26 to the 1/3 equals negative t plus 12. And I need to solve this because they want the equation as h of t. Sometimes if they don't say that they need it as h of t or something like that, you could just go ahead and leave it at this. But they specifically said here they want h of t. So I need to separate this out and solve for h. So in this case, I'm going to divide everything by 3. So divide by 3, divide by 3, divide by 3. So this will be h minus 26 to the 1/3 power equals negative 1/3 t plus 4. Now I'm going to cube everything at this point, and I'll get h minus 26 equals negative 1/3 t plus 4 to the 3rd power, and bring that 26 over so I can rewrite this as h of t equals negative 1/3 t plus 4 to the 3rd power plus your 26. There is my equation for h of t. You could have had this in a couple other formats. You could have just said negative t plus 4 over 3 to the 3rd power. You could have left it like that. That's fine since it's free response. Okay, so then we need to just finish this problem out and determine what the temperature is at time equals 3, because that's what they asked for right there. So let's go ahead and do that. And this will be h of 3 is going to be negative 1/3 times 3 plus 4 cubed plus the 26. That becomes negative 1 plus 4 is going to give me 3. Cubed will be 27 plus your 26. That's going to give you a temperature of 53 degrees Celsius. That's what h of 3 is. So we've got it, we've finished the whole problem, and that's pretty much it. Now, how does this go as far as scoring? You know what? Usually, out of 9 points, I don't know how they're going to determine the point values this year. I have to look that up for you guys. But usually out of 9 points, this part C on these separation of variable ones is 6 points. So they'll give you maybe 1 point for here, or in this case, they'll give you 2 points, 1, 2. Saying that it's an underestimate there will give you 1 point, and then over here, here's the rest of them. So that's 3, and then here would be the rest to make it a total of 9 points. So that's typically how it works. That part C is usually the biggest part. So hopefully this helped. Again, on these problems, make sure you do them on your own first, and then check out the video and follow along. So thanks for watching. Hit that subscribe button, hit that like button, and I'll see you guys in the next video. Oops.